So we're picking up where we left off in section 1.2, and we have two main topics for today. We'll be talking about graphical analysis of functions, and then we'll also be looking at even and odd functions. So a lot of what we're going to do here is going to rely on a graphing calculator. If you don't have one yet, you can do these problems using Desmos, but let's please get those calculators as quickly as we can. And you might want to write down, well, actually, the button presses are here. So let's go ahead and get started on this first one. We're going to graph this thing. So get out your graphing calculator. I want you to check a couple things in the mode. The mode button is up here near the top. If you hit that, the important things for us today is that you are in function mode. So there's function, par, polar, and sequence mode. We want to be in function mode. And then other than that, I don't think there's anything that we need to worry about. So go ahead and hit the y equals button. It's up in the top left corner. This is where we're going to put in our equation that we'd like our calculator to graph for us. While we're here, before we put in any equations, some of you are going to see plot 1, plot 2, plot 3 up at the top. We do not want these highlighted. If you use your cursor and put it over top, you can hit enter, and that will highlight that. We do not want them highlighted. So if any of yours are currently highlighted, go ahead and move your cursor and unhighlight those. That will cause errors when you go to graph. If you're not seeing those, then don't worry about it. It's okay. You should be good to go. So we're going to go ahead and type this equation in. This says y1 equals, that's just like our f of x here. So I'm going to start with x to the fourth. Okay, plus 5x to the third, minus 2x plus 6. Some of yours are going to look a little bit different from this. Some of you might have yours actually showing the exponent as a little exponent rather than a caret symbol with a number after it. And that's, there's a mode setting where you can switch between those. Just make sure that if yours has the fancy exponents, that you're moving your cursor off of the exponent before you go to your plus 5x. All right. If we want to look at our graph, we hit the graph button, but I'm going to ask you to do something else instead. Whenever you're going to hit this graph button, the first time you're graphing something, we want to take our graph back to the standard zoom level. So instead of hitting graph, I'm actually going to hit the zoom button. And I'm looking for an option that says zoom standard. The standard zoom should be option 6 on your list. Zoom 6. And when you hit that option, it's going to go ahead and graph. It almost looks on my screen like I have like a grid paper there, but that's just aliasing on the screen. So you should be seeing something that looks kind of like that. Is that what you guys are seeing? Anybody having any trouble? This is our first time using these, so we'll need to do a little bit of troubleshooting. We feeling okay? All right, do you get a general idea of what this graph looks like? I'd say, yeah. Can we see the entire graph, though? I'd say there's probably a little dip down here that we cannot see. Would you agree? So the reason for that is because our window is set up. The window settings tell the graph how far to the left, how far to the right, how far up, and how far down to graph. And when you do that zoom 6, it sets all of those things to tens and negative 10. So if you count it over, we got 10 tick marks this way, 10 tick marks this way, 10 this way, and 10 this way. I think we need more tick marks down below in order to see the bottom of this thing. So the way we tell our graph that we want it to show more down below is in the window setting. So hit that window button. And this is where you tell your calculator how far to the left. So x min, remember x is in the left and right direction. X min tells it how far to the left to go. X max tells it how far to the right. X scale tells it where do you want your tick marks. Do you want your tick marks every 1 unit, or every 5 units, or every 10 units? For some of our applications, we're going to want tick marks every 1,000 units. Okay, usually that'll be 1. Y min is how low, Y max is how high, Y scale is where your Y tick marks are. And then the X res and this other stuff, I don't really know what it does. Leave it alone. All right. So what one do we need to change to make this thing go lower? Y min needs to be lower. We've got it going down to -10. Does anybody want to make a guess how low we need to go to see that little lump down at the bottom? More lower than -10. What do you think? -100? -100? I like, so you're going big, and that's a good strategy to use. And then see if, and then maybe we'll need to go back and bring it a little bit closer, but that's a good strategy. So we're going to go -100. It's probably going to be too far. I'm guessing it's going to be too far, but we'll get an idea of how much too far, and then we can come back. And a lot of the times when you're adjusting your window, it is kind of a guessing game. You're going to try something, you're like, that wasn't far enough, or that was too much, and I'm going to go back and try something different. So I've got it at -100. I'm going to go ahead and graph it again. You can see that now my graph is going a lot more down than it was up, because we're only going up 10 in this direction, we're going down 100. And these tick marks are very, very close together. So I'd say we went further than we needed to. We're able to see the whole graph, but we kind of lost. You guys remember there was a little wiggle up here, and it's hard to see that right now. So I want to kind of dial it back a little bit. We really only need to go down to here. Someone want to estimate how far down that is? This is 0 and this is -100. What do you think? -60? Yeah, go back to your window and change your Y min to negative, I don't know, let's try -60 and see what that gets us. Yeah, I think that's good. And we can still kind of see that wiggle up top. So adjusting the window is going to be one of those things that you're going to get used to over time, especially when you're doing an application problem. Let's go ahead and sketch this thing. So in this class, when I say sketch, it does not have to be on graph paper. I purposely did not give you graph paper this time around. We're going to make a rough sketch, but we want to try and get the most important features relatively close to where they belong. So I'm going to make a sketch of this thing. It goes way down like this, and then it comes back up. And there was a little wiggle here. And I exaggerated that wiggle a little bit. Now we're going to learn how to find exact values for lots of the important features on this graph. Eventually I'm going to show you how to find x-intercepts. Actually, approximate values, I should say. So I'll teach you how to find the decimal approximations for these x-intercepts, for this y-intercept. But for today, I want us to focus on local extrema. Local extrema are the places where the graph turns around. I'd say this point, and this point are our local extrema. They're the hills and valleys on our graph. They're local maxes and local mins. Why do you think they include the word local min? What does local mean to you? Hmm? Yeah, not close to, but not like the absolute. So like this point here, is this the lowest point on the graph? On the entire graph? It's not, but it's the lowest point kind of in its neighborhood, right? So this is a minimum. It's not the minimum, but it is a minimum. It's the local minimum. Does that make sense? Would you guys do me a favor, and above where that says local extrema, can you please draw a star? I'm going to put this in red. And put in quotations, turning point. Turning points. Our book calls them local extrema. Other books call them turning points. Those of you who will take this course for CWU credit, when you get to your final exam this semester, they are going to ask you for turning points. They will not ask you for local extrema. As we go through the course, I'll point out those kind of differences between our textbook and the vocabulary that you'll see on the CWU exam. And then right before the exam, in those couple weeks while we're reviewing for the exam, I'll go back through those things with you and say, okay, just as a reminder, we call them local extrema. On the CWU exam, you're going to see turning points. Once you get used to that. Okay, let me show you how to find these things. So I'm going to kind of talk you through it. I'm going to show you once. I don't want you to use your calculator the first time I show you, and then I'll walk you through it slowly. So I'm going to start by finding this point here. And I'm going to use a function on my calculator, and it's going to ask me 3 questions. It's going to ask me for a left bound, a right bound, and a guess. So my calculator is not smart enough for me to just say, find me the local minima. I have to tell it specifically to find this one. And I don't know exactly where it is, but I can kind of tell the calculator to look sort of in this area right here. And the way I do that is I tell the calculator, what's the left edge of this box, this search box, what's the right edge of this search box, and approximately where's the middle of this search box. So when they ask me for a left bound, a right bound, and a guess, I'm telling the calculator, focus your attention in this portion of the graph and find me that local min, okay? So I'm going to walk you through this once. Please just watch the first time, and then we'll come back and do it together a little bit slower. So I'm looking for this local min. So I'm going to do second calc. The calc is the trace button. We'll be using these options a lot. And it is a local minimum, so I'm going to go down to option 3 and hit enter. Just watch for right now. You can see in the lower left it's asking for a left bound. So I need to use my arrows to move my cursor so it's a little bit to the left of that local min. So I'm going to use my arrows. You'll see it'll trace the function as you're going. And I'm going to move it a little bit left, right there. Or I could do like right here. Well, maybe not right there. I could do right there, I could do right there, I could do right there. It just has to be noticeably to the left, okay? So I'm going to say there's my left bound. I'm going to hit enter to tell the calculator that's as far left as I want you to search. Now your calculator is either going to put a vertical line on here, or some of you will just have a little arrow here that'll say, okay, that's the left bound of my search. Next, once you hit enter, it's going to say right bound. So again, you're going to use your arrow keys to move that cursor. So it's just a little bit to the right of that minimum. How far to the right? Doesn't really matter as long as it's to the right of it. You're going to hit enter. What I've now told the calculator is focus your attention just on this area of the graph to find me a minimum. The last question it asked me for is a guess. I'm going to move my cursor kind of close to the thing. It doesn't need to be right on top of it. You're just giving it basically a starting point for its search. It's going to think for a while, and then it's going to spit out some x and y values for that local minimum. So these x and y values would be the decimal approximations for that local minimum. Okay? So I'm going to walk you through that whole process again right now. I'm moving my cursor so it's not over top of that. If you've got your calculator with me, follow along. We're going to hit second calc, which is the trace button. Go down to minimum. Hit enter. It's asking you for a left bound, so use your arrow keys to move your cursor so it's a little bit to the left of that minimum, and hit enter. And then again, so it's a little to the right of that minimum, hit enter. And then the guess, you're just going to try and get it kind of close to that point. Hit enter, your graph, or your calculator will think for a little bit, and it'll give you some answers. And we're going to go ahead and write down the coordinates here. In this class, if I don't specify, please give me 3 decimal places, the nearest thousandth. So this point's coordinates, according to my calculator, are negative 3.714, comma, negative 52.454. And I'm just going to indicate that that is a minimum. All right, does anybody need any assistance with finding those? You should be seeing those. I did round in both cases. I had to round the third decimal place because of rounding rules. Yeah. So as we go through this and you're learning to use these, you're going to get some errors that are going to pop up. And I'm always going to ask, can I put this up on the screen so that we all can learn how to troubleshoot these things? Because they are, I mean, they're not as smart as your smartphones are. You've got to kind of learn how to use these things. And again, that's why I'm encouraging you to get a calculator as soon as you can so that you can be messing around with these. So this window range is going to come up pretty frequently. This probably happened when you hit the graph button. Okay, and what that usually means is your calculator is probably confused about the window settings here. So my guess is if I go into my Windows settings, because that was my error type, that I'm going to see something that's causing my calculator to be confused. So I'm going into Windows settings. Oh, I got to hit quit first. Going into my Windows settings, and I'm going to look through here and see what might be confusing to the calculator. And I can see it right here. My Y min is 60 and Y max is 10. Why is my calculator confused? My min is higher than my max. The calculator is like, oh, I can't do that. You want me to start at 60 and go up to 10? It can't go backwards. So I think when you type this in, you meant to put in negative 60. So if I go negative 60 here, now, okay, now it should be good to go. All right. So window range error usually means that there's something in there. And I'll tell you, like, a lot of times for me, it's like because I type in, I meant to go from negative 10 to 10, and I forget the negative, just like happened a second ago, and I tell it to go from 10 to 10, and the calculator is like, how can I start and end at the same place? That doesn't make any sense, and it'll throw that error. All right, thank you for that question. Any other questions? You guys feeling all right? All right, we got to find these other 2 points. Now, I'm going to go back to my graph here. I guess I'm already there. And there was a local max and a local min. When we zoomed out, we made it kind of hard to see those. Now that I've got this down here, I'm going to go ahead and zoom back in on this region. I've got all the information I need down here. I know exactly where this is. So let's zoom back in on this top region so we can see, kind of see where that dip and that hump are. So do you guys remember the button that's going to get us back to our standard zoom setting? I'll give you a hint. The first thing you push is the zoom button. And if I'm looking for my standard zoom setting, I go to zoom standard, which is option 6. So zoom 6. The reason I'm doing this is I want to be able to, I've got to give it a left bound and a right bound for this max and for this min. And it was so zoomed out that it was kind of hard to see that there was a max and a min. So this is even, you know what, I might zoom in a little bit more on this. If I wanted to just kind of see this area of the graph, give me an X max and an X min that I could use here. From where to where in the X direction will we need to go? Just to kind of see this portion here. What do you think? In the X direction, negative 2 would be plenty, wouldn't it? Negative 2 up to 2. I'm going to zoom it in, so I'm going negative 2 to 2. So go to your window, and I'm telling the X to go from negative 2 to 2. And then go back and graph it. So you see how it kind of zoomed in the X direction? If I wanted to, I could have it zoom in the Y direction too. If I wanted to catch this and I wanted it to kind of take up the whole screen, I could tell it to go from, I don't know, like 3 up to 9 in the Y direction. I'm going to have it go 3 to 9 in the Y direction. Go back to your window. Tell it in the Y direction, go 3 to 9. We're hoping to see that peak and that valley really nice and pronounced. That's good. That's good right there. All right, so let's go ahead and we learned how to do a min already. Can you guys follow the steps that we did just a moment ago to find that min? If you're sitting next to somebody who doesn't have their calculator today, could you let them borrow yours and try this out if you're willing? Those of you who don't have a calculator, you're going to do all this in Desmos. You're just going to graph it in Desmos, and there will be a point that you can just click on that'll show you the max and the min. That'll get you through our assignments for today. We want to get those calculators as soon as we can. And again, if we have time, we're going to have to boogie, but if we have time at the end, we'll do that. Yes? What's it doing? Oh, so it's negative versus a minus key. There's two different keys, just like on those yellow calculators you used back in last year. Yeah, I don't know why the TI calculators have a separate negative and minus. Did that fix it? Okay. So I'm going to go second calc minimum. So second trace minimum. Left bound, right bound guess. So I'm moving my cursor a little to the left of that minimum, a little to the right of that minimum, and right on it. And then I'll write down those coordinates. And for those who don't have a calculator in front of you, it is 0.349, comma 5.529. All right, we've got a max here as well. To find the max, there's one small change you need to put in that button press sequence. You're still going to do second calc. We're not going to use minimum this time, though. We're going to use option 4, which is maximum. It's still going to ask you the same three questions, left bound, right bound, guess. So move your cursor a little to the left. Little to the right. Oops, that's not what I meant to do. Can I recover here? I think I got to start again. A little to the left. A little to the right, and then kind of right on top of it and hit enter. Now, by the way, I didn't need to zoom in this close in order to do the max and the min. I would have gotten the exact same values. It just makes it a little bit easier to see. So this max is happening at about negative 0.386, comma 6.507. That's a max. This is a min. All right. Questions up to here? Have you all learned increasing and decreasing already? You have? So when you look at this graph, are you able to identify a couple of regions where the graph is increasing and a couple of regions where it's decreasing? So I'm going to color code these on mine. So increasing, I'd say this graph is increasing on this interval here. As from left to right, we are going uphill on that interval, and it's also increasing on this interval here. We're going to come back and write those intervals down in just a moment. It is decreasing on this interval and on this interval. Sometimes my students, especially when they first learn this in Algebra 1, they get thrown a little bit by the arrowheads. Some of my students would look at this arrow and say, no, that's increasing. The arrow is going up. But you guys have learned it's always left to right. Awesome. So we're going to do intervals for this, and when we give intervals for increasing and decreasing, we always give x values. we're going to give x values. So I'm going to just go through and highlight my x values for these 3 key points. Those 3 numbers are going to appear in our intervals for increasing and decreasing. So my first interval is from this point to this point, so I need to go from this x value to this x value. And then there's another interval with a break in between, so we use that union symbol. And that's from this point to infinity. Now, when you look at solutions in the textbook, do you guys know there's odd numbered answers in the back of most math textbooks, including the ones that we have? So if you were to look up the solutions to a problem like this in our textbook, they would actually use square brackets around increasing and decreasing intervals. Not the infinity part, but the rest of them they would. I disagree with that. Our calculus teacher disagrees with that, but it's not something that you do whatever you want. Okay. So if you were to use square brackets here on a test or a quiz, I wouldn't take off for it because that's the way our textbook does it. I personally don't think that a graph can be increasing or decreasing at the point where it's changing. I don't think that should be included, but the textbook believes it should. So that'll happen from time to time. But you can form your own opinion. Infinity always gets a parentheses, but if you use brackets here in these 3 places, you'll get full credit. All right, decreasing. It's decreasing from negative infinity up to this point. And then it's also decreasing in this really short interval here between these 2 x coordinates. If you use Desmos for this, I think you'll only be able to do 2 decimal places. That's fine for now. Are we good on increasing, decreasing? All right, we're going to graph the next one, and I'm just going to focus for the sake of time. I'm just going to focus on the, oh, you know what? They asked for domain and range here. Let's do domain and range really quickly. Domain and range, interval notation. So domain are all the x values that are allowed to go in the function. There are all the x values that appear on the graph. Are there any x values that don't appear on this graph? So the domain's going to be all real numbers. We're going to write it in interval notation, though, negative infinity to infinity. So there's no breaks. Arrowheads point to the left and right. So negative infinity to infinity. The range is not all real numbers, though. Is this graph bounded above or bounded below? Bounded below. So the range is going to start at a low value and go up to positive infinity. What's the lowest? Remember, range are y values. What is the lowest y value that appears on this graph? This negative 52.454. That value does appear on the graph, so it should get a square bracket. And it goes to infinity. All right. Let's skip this for now. We might come back to it if we have time. I think we've hit most of the important stuff here. Yep, we should be good. All right, this is the more technical part of today. So there are two goals for today. Were graphical analysis, especially maxes and mins, increasing and decreasing. That was a lot of button pushing. That's one thing that you guys are going to get good at is you just practice it through your assignments. Even and odd, this is a more mathematical and technical concept. So there are some special types of functions that are called even functions or odd functions. Not all functions are even or odd. Most of them are not either one of those. But sometimes a function is even and sometimes a function is odd. Did you guys learn about even and odd last year? What did you learn about it last year? We might be able to truncate this a little bit. Did you learn about symmetry? Did you learn about looking at exponents? Maybe. All right, we'll just assume that we don't know anything. All right, they have to do with symmetry about the x-axis or about the origin. So an even function is going to have, the y-axis or the origin. An even function is going to have symmetry about the y-axis. And what does that mean? That means if I pick out a point over here, go ahead and highlight a point over here. That point's going to have some coordinates, and I'm going to write these coordinates down, and this may look a little strange to you right now. We're being very technical here. It's got an x coordinate, and instead of writing y, I'm going to write f of x. X comma f of x. It's just like x comma y. That point, if there's symmetry about the y-axis, that point should match up with another point on the other side of the y-axis. Can you find the corresponding points on the other side of the y-axis that would match up with this? It would be over here. And this point here would also have some coordinates. I'm going to write its coordinates down. Now help me out. If this point over here has a coordinate of positive x, this one should be the same distance away but on the other side, right? So what's the coordinate? What's the x coordinate over here? It would just be negative x. So it would have an x coordinate of negative x, so then its y coordinate would be f of negative x. All right, so here's the big thing about even functions. The algebraic definition of even functions has to do with the y coordinates. What is special about the y coordinates of these 2 points? They are the same. They're exactly the same. They're both the same level vertically, right? So x and negative x have the same or equal y coordinates. So the technical algebraic definition of an even function is a function for which f of negative x is equal to or the same as f of x. This is going to become really important. I'm going to draw a box around it, put a star next to it. I need you to understand and know that an even function, the definition of an even function is one for which f of negative x is equal to f of x. F of the opposite of x is equal to f of x. We will be recalling this throughout chapters 2 and 3. We'll come back to it again in chapter 6 in the second semester. All right. Odd functions are functions which have symmetry about the origin, meaning you can turn that function 180 degrees about the origin and it would look exactly the same. All right, let's do the same thing. Can you pick off a point up here on our odd function? And let's write the coordinates of this point. Again, we're going to do some generic coordinates. We're just going to call it x and f of x. Now find me a corresponding point on the opposite side of that function, the one that would correspond to rotating this around 180 degrees. It would be down here someplace. And let's write the coordinates for this point. Would you guys agree that just like before, they're both the same distance away from the origin? This is positive x, and this would be negative x over here. Are we feeling okay about that? So this is still negative x, which makes our y also f of negative x. But there's a key difference in this situation compared to what we just did. Are these y coordinates the same this time? They're not the same. What's different about them? How are they related and how are they different? One's negative and one's positive. That's key. How are they related? How is this distance here related to this distance here? The distance is the same. It's just that one's positive and one's negative. So this time around, I would say that f of negative x is just the negative version of my original one. Would you agree? If this was 7, then this would be negative 7. If this was 25, then this would be negative 25. Agreed? So whatever this is, I just need to take this and stick a negative in front of it. So there's our formal definition. So I would say that they have opposite y coordinates. When we say opposite in mathematics, we're talking about positive versus negative. So in this case, f of negative x is equal to the opposite of f of x. And this is the formal definition for an odd function. Does every function out there fall into one of these two categories? No. No, these are two special categories of functions, but most functions don't fall into either of these. They do have specific properties that are going to be helpful for us later on this semester and then when you get into calculus as well, which is why we are going to see this come up again and again throughout the year. So even and odd. So we're going to practice showing or checking that functions are even and odd algebraically. This is a process. This is one of those things where I'm going to get kind of picky about what your work looks like. So please make sure you copy down exactly the steps that I'm showing, and then when you do these in your assignments, please show all of your steps. All right, so we're going to look at some functions here. You have the option of either going across your page or down your page. I'm going to go across, but so I know some of my students like going down the page as well. So here's my function. I'm going to start off with this one. We'll call this number 1. And we're just going to follow step by step here. So what we're going to do is we're going to start with always with f of negative x. And I need you to write down f of negative x. Not what it is, but write down actually f of negative x. Our goal is to write a bunch of equal signs with some different versions of this and either get back to f of x or negative f of x. If we can get it back to f of x, then we're going to say it's an even function. If we can get it back to negative f of x, then it's an odd function. If we can't get it back to either one, then it's neither. All right, so f of negative x. So I'm going to write f of negative x, and then I'm going to write equals. And then I'm going to go ahead and do that substitution. If I gave you this function and I asked you to find f of 2, you guys would all be comfortable with that, right? Please say yes. Please say yes. That's an Algebra 1 topic. If not, come see me and we'll talk about that. If I said find f of 2, you would just plug 2 in for all the x's. If I say find f of negative x, you're going to do the same thing. You're going to pull all the x's out and put a negative x in there. So copy down your function, leave out your x's with a blank parenthesis in its place, and substitute that negative x in place of all those x's. In this case, it's just 1. So we're substituting. I'm going to go ahead and label this. You don't have to do this in your assignments. I just want it to match up with the steps that are written up above here. So that's our substitute step. And then we're going to simplify it. All right, what can we do with this? What's going to happen when I square this negative? When I square this negative, it's going to become a positive, right? Any even power is going to basically strip away a negative on something. So when I simplify this, it's just going to become negative 4. The negative is going to go away in here, so I don't really need the parenthesis anymore. It's just x squared plus 2. Okay, we okay with simplifying? All right, from here we're going to check. Does that match our original function? It does, totally, perfectly matches what we started off with. Agreed? So then I can finish this and say, oh, then that equals f of x. Right? F of x was this thing. Agreed? So what we have done for this particular function is we have shown that f of negative x is equal to f of x. We've shown that explicitly through a couple of steps. And if f of negative x is equal to f of x, that means what about this function? It's even. On a test, if you left out any of these 4 steps, you would be losing points. Okay, all 4 of those steps need to be written down. You're always going to start with f of negative x, and you're going to end with either f of x, or sometimes you'll end up with negative f of x. Let's do another one. You guys have any questions on that one? Oh, I thought we were going to have more time today. That's all right, we got this. We're going to start with f of negative x equals. Let's do our substitute step. So I'm going to rewrite my function. I'm leaving out all of my x's. There's 2 this time. And we're going to replace all those x's with negative x's. And then we're going to simplify this. Now what happens when you cube a negative? It's going to stay a negative. So this is going to become negative x to the 3rd. So odd powers are going to keep the negative there. What's going to happen with this negative 6 and this negative x? Negative times a negative, that's going to become a plus 6x, isn't it? Is that the same as the original function? It doesn't match, does it? So what do we know for sure? Not even. So it's not even because it doesn't match. We're going to do one more step. So if it doesn't turn out to be even, our next step is to factor out a negative 1. If I factor out a negative 1, I'm going to have a negative on the outside, set of parentheses inside. And what will we have inside the parentheses? If I factor a negative out of this, I'm going to have a positive x cubed. If I factor a negative out of this, I'm going to have a negative 6x. Is that thing in the parentheses equal to the original? Ooh, so what have we found? We found that it's equal to the original f of x, but with a negative out in front. So we started with f of negative x, we ended up with negative f of x, and when those 2 things match, that tells us that we are dealing with an odd function. We're going to do one more here. Any questions on that one? Let's go down to this last one here. Skipping down to here. All right, let's start out with f of negative x. We'll do our substitution step. Got lots of x's to replace this time. All those x's get replaced with negative x's. All right, you guys remember the rule with the negatives and the odd and even powers? Odd power, the negative stays. Even power, the negative goes away. We've got all odd powers here, so this is going to end up being negative x cubed. We'll end up with a plus 4x. On the bottom here, we have negative x to the fifth and a minus 3x. This one's going to surprise some of you. What do you think? Is it even? Do you think it's going to be odd? This is a tricky one. Definitely not even, right? Does not match. All right. So next we're going to factor out a negative 1. Now, how do you factor a negative 1 out of a fraction? Do you factor a negative 1 out of the numerator, or out of the denominator, or out of both? I'll give you a hint. 2 of those options are correct, and 1 is not. When you factor a negative out of a fraction, you can either factor a negative out of the top, or you can factor a negative out of the bottom, but you can't factor it out of both. And here's why. If I have a fraction and I factor a negative 1 out of the top and a negative 1 out of the bottom, what have I actually factored out of this fraction? I factored a 1 out of it, not a negative 1, because those negative 1 over negative 1 would cancel. You can't factor it out of the top and the bottom. You can factor it out of one or the other. Usually we do it out of the numerator. So I'm going to factor my negative 1 out here. It's going to be a negative on the top. The denominator is going to have to stay exactly as it was. That would make this a positive x to the third, a minus 4x. And I might go one more step here. I do that negative out in front of the whole thing. So clearly it did not match the original, but when we factored a negative out, does that now match the original? It does not. So it's not even, it's not odd. This one is just a regular old function. All right. Make sure you're showing me your steps on these, please. And that's what we got time for today. I did not have time to send folks down to the library today.